than all of them to see if you have a resistant strain or not. And a lot of people, like some people harbor.
Yeah, sure, go.
You
guys ready?
Okay. We did this, we just approached it as mentioned differently. So Jake and I are both going to talk about the article that we read, and then we're going to hand off to Evan and Susan. They will talk about our painting. And we combined the art concepts and the science concepts from both the article and the painting. So I'm going to hand off to Jake, and he's going to begin with the article.
Yeah, so a quick summary of the article we read, which was called Computer Art Graphics, Integration of Art and Science. It was actually really interesting. What the author did was they set out to see if students that were in a physical geology class, if the students that were in that class, a portion of them also took an unrelated, well, related but not required computer art graphics class at the same time, if those students would perform better than the students who were not in that art class. So there was like 50-something kids that took both of the classes. Demographics were basically the same. And so in this one credit class, in the computer arts class, they took concepts and data from their geology lecture and represented them through graphic computer art. So it was really neat. Actually, the experiment group, the group that took the class, performed more poorly on the science pretest. But then at the end of the class, they ended up testing better for the post-test, overall grades, and lab scores. And then from the art side of things, they were also trying to find out if in some way they could correlate an increase in their artistic capabilities throughout the course. At the end, they have these judges go and look over all these art pieces and kind of grade them. And it didn't really find that the artists judged the art to have gotten better as the semester went on. The author thinks that was probably due to the fact that they had to learn new software like each week, so they were using new techniques. But from a science perspective, it's really cool because the kids perform better by doing this visual representation of the scientific concepts. So that was just sort of more like a hard data type of an analysis of what we've been talking about how it really can benefit. The numbers are there to back it up. This was a college class, but I think we can probably expect that it would help out for secondary or even elementary too. So a couple of the scientific concepts that I would mention for this paper are just data in general. Like in science, we always talk about how we want to explain natural phenomenon by using empirical data. And data is really just a word for information that typically comes to us in the form of numbers that we can manipulate statistically in order to create an argument about something that we've seen. And then what was really cool about this article was that they were actually using computer science to create graphics. So it was, that aspect of it was its own integration of art and science. What is a graphic? It's just a visual image, right? But they were using a technology and science in order to create those visual graphics. And in some ways it was also, there's another really cool sort of play on this with modeling that both art and science concepts both use. The graphics are in some ways a form of a scientific model, and Rachel is going to talk about the artistic model too.
So modeling relates to this very well because in art we use 2D and 3D modeling. 2D modeling is usually done in graphic design, which really relates to the graphics that they were making with geology. So we make representations that are 3D, but they're on a 2D computer, and that also relates to a 3D modeling that we do. Clay and wax are traditional modeling materials, but sculptors that use clay and wax that make those for maquettes, which are small representations of a larger work. They use these graphics as well. Sculptors use graphics to check proportions. We need them if we want to write a grant. We all usually need some kind of graphic representation of what we're hoping to make, so sculptors use this as well. These proportions, of course, like I said, relate to space, which is what I'm also talking about. So we learn space pretty naturally. We like to see things evenly proportioned, evenly spaced, things like this. And that relates to what he was talking about with the graphics. These students had to make these graphics that were visually appealing, and that leads into my third topic, which was composition. So composition is also kind of inherent. We look at things and we use it in science, art, music, as Adam talked about. Lots of people mention different things about how we use composition. So composition is the use of elements, and especially like art elements, space, line, color, things like that, in a picture plane. And in science, we use different kinds of elements for that. But all these make up a composition. So with that, I'm going to lead over to Susan, who's going to start talking about our composition, and later Evan's going to talk more about composition.
Okay, so our picture is of a soap film. So it has all the different colors in it, and I looked up the way that works, and it's diffraction is what's going on. So basically, light is coming, and it's bouncing off of the soap film, and it's also bouncing off of the inner layer of the soap film, and the diffraction between the two films. So the difference in not wave phase, but the difference in like position and stuff of the light as it's gone through creates the different gradient that got it down there, of course. And the different colors come from the fact that the film isn't perfectly one thickness. It varies a little bit, so the colors differentiate themselves a little bit differently. So kind of like a prism, if you guys have seen those. And then we got really curious about how silk painting actually works, like the chemistry of the silk painting. So one of the words on there is antipathy, and that means not feeling. We got curious how the wax resist actually resists the water. And what I found out is that it's basically just hydrophobic, which is a word that we didn't put on there at the time. It means that it resists water. So because the paint is wet and it's water-based, having something that resists water makes it so that the water can't go around it. So it just makes a physical barrier that the water can't mix with, kind of like oil. It can't mix with water, so the wax resist works the same way. And then the last science concept on there is heat transfer, and I went looking for information on it, and I couldn't find anything that specifically talked about why you need to heat set the silk. It said that some paints require heat setting, others don't, but the heat setting makes it more permanent. What I think is going on, and somebody can feel free to correct me if they think I'm wrong, what I think is going on is that it dries out the water from the paint, which makes the pigment itself bind to the silk. So when you pour water on it to wash it again, the water doesn't just take it right out, because otherwise you're just re-wetting wet paint, and that can just remove it. So I think that's what's going on. Do you want to talk about?
Yeah, so it's kind of, it's really kind of hard when you get into this, not to separate, there's just so much in common with the vocabulary. My 3 words, there's gradient, and I looked up gradient, the mathematics of gradient, a little bit above my head, but it is part of the concept in science of density. So in art, we try to, a lot of times, we have a word in art called chiaroscuro or chiaroscuro, which means dark and light, the play of interplay of dark and light. And that's definitely something that's used in places like astronomy and stuff like that. As far as color, you guys have already covered a lot of the electromagnetic spectrum. All I want to say on that is that we have a thing called Roy G. Biv, and the warm colors, which are the lower wavelengths, are at the bottom of the scale, and the higher colors, which are at the top of the scale, all the way to white, they are the most intense radiation. And this kind of goes into just a little bit into the visual perception of color. So if you're looking at, it used to be thought during about Newton's time that like this was gray, and what they found out is that it's not actually the object, it's the radiation bouncing off of it into your physiological makeup. So like black, for example, absorbs all radiation, and white is actually every single color in the spectrum. Therefore, that like they were talking about with the snowflakes. So, and then just real quick thing on color. It's really, we couldn't quite figure this out, but in the art world, we talk about red, yellow, and blue, the primaries, and the tertiaries, and you guys went all through all that. Now in the printing world, it's changed. They have what's called cyan, magenta, yellow, and it's called CMYK, and black is K. So it's very different from what we do in art. And then in science, there's red, green, blue, which is basically used with, like if you were to project those colors, that's how the color is dictated in science. So I don't know what other disciplines art shares with the fact that they use red, yellow, and blue in the original primary makeup of colors. So, and the last thing is composition. In art, we talk a lot about studies. We do studies of things. So sometimes they'll do a study of a hand, a nude study or a still life study, and it's really the same thing if you think about it, because nature or science is all about describing phenomena of nature, and so art, really in a similar kind of way, is all about studying nature. So they really are close. And we did talk about one thing as a group, that it's really nice in the academic setting, whatever school you're in. Scientists tend to be a little more rigid, a little more logical, and sometimes artists tend to be a little bit, lighthearted and kind of free-spirited. So we talked about how it's really good to have both of those types of dispositions working together, because it stops. If someone's getting a little too rigid, it's like, yeah, mellow out. You know what I mean? Do a painting. And then if an artist is kind of just doing what he wants, it's like, maybe go do a math problem. So that's all I got.
Nice job.